Hello everyone, my name is Tarun and I'm an engineer at Dragonfly. In today's demo, we'll talk about the custom rollout strategy in Dragonfly Operator. So instead of leaving it to Kubernetes on doing an upgrade for your Dragonfly instances, the Dragonfly Operator in Kubernetes takes care of its own. So essentially, when you try to update a multi-replica instance uh, with any of the new configuration or anything like that, right? Instead of leaving it to Kubernetes, the Dragonfly operator chooses the order in which the pods get upgraded. This means it will first start with replicas, and then only when the replicas are ready, it'll go and update the master, right? So this means for any reason, if you have wrong configuration, for any problems, you always have a ready replica to which you can always fall back to. This is all done automatically by the operator. So this is awesome, right? So that you don't have to worry about the order in which your pods get upgraded, and also the operator is now involved in this whole process. So let's look at it, right? Let's see how it works. So first, I have a Dragonfly instance here called the Dragonfly sample, where we have three replicas, right? Obviously, three replicas means you have like three instances means you have two replicas and one master. So which one is the master? If we see, the master is the sample 0, and the other two are replicas, right? That should be the case, right? So now let's insert some data before we do anything here. I'll do set 1 2. Now this means now we are adding data, and we'll do a rollout after adding data, and expect the data to be there, and also we'll see in which the in which the order in which the rollout happens. So what should be the upgrade? So essentially, let's edit the Dragonfly sample object, right? I'm thinking maybe I'll add a couple of resource requirements to the pod. Rep request 200. These values are good. Now let's up. Now once we close this, we have triggered an update on our Dragonfly instance, and because these are resource requirements, you require the pod to be teared down. Now, if you see what happens here, you should see that the upgrade strategy should start from replicas. So 1 or 2 and then go to 0. So as you can see, it shows 1 first, 1 is getting upgraded. Now, if you see one, like once the pod gets restarted, you should see that it has the resource requirements that you specified. And then it should choose 2 only after like 1 is ready and has all the data, right? This is done by using the replica offset, by checking if the replica offset. So now 1 is ready, 2 is terminated now. A new 2 got created, it's already running. Once it's ready, we'll go back to 0, which is the master. So during this master, right, when we delete the master, one of the other 2 pods between 1 and 2, who are the new replicas, would be the new masters, and the operator automatically selects the new master between 1 and 2. And the other awesome part is when it selects the new master, it also runs this through the REPL takeover command, right? Which means before we upgrade to one of the new replicas, we actually lock the new master from taking any new client connections, and we make sure all the data is done, all the data processing, if there is any, all the thread processing is done, and then choose the new master, and then the transition happens. This means there is no data loss in between the transition where the clients are still writing, etc. Now this is all done. Let's see who's the master and replica. The replicas are 0 and 2, which is what we want, and 1 is the master now, which is nice. Now if we look at the data, if I do get 1, we should see that the data is still there. None of the data is lost. Yep, as you can see, we got the answer. So as you saw here, a custom rollout strategy of the Dragonfly operator makes sure that the update strategy starts with replicas and then goes until the master, and also using the Dragonfly commands there on when this transition happens to the new master, the REPL takeover Dragonfly command to essentially make sure that there is minimal data loss during the transition. Thank you.